We are currently living through the hottest period in recorded history, and the temperatures driving that reality are about to surge even higher. This chart tracks subsurface temperature anomalies in the Pacific Ocean. The bottom row maps April 2026, revealing a massive heat pool building below. Comparing it to the top rows, tracking the massive 1997 and 2015 events, the current warming tracks even higher. A heat pool of this magnitude acts as a massive atmospheric engine, capable of triggering severe disruptions to weather systems across the globe. To understand how this works, we need to look at the Pacific trade winds. Normally, these winds blow from east to west, pushing warm surface water toward Asia. But during an El Niño, those winds weaken. The massive warm water pool slides back east against the Americas. This creates a physical cap on the ocean. A thick surface barrier completely stops cold, nutrient-rich water from welling up from the deep. The planet has weathered these cycles for millennia, but the 2026 event is forming on an ocean already boiling from human-caused global warming. We are literally watching a natural anomaly collide with an unnaturally hot baseline, creating a powerful climate multiplier. When that cold, deep-water upwelling stops, the supply of nutrients is cut off. That starves the microscopic plankton at the ocean surface, entirely wiping out the very foundation of the marine food web. The existing baseline heat acts as an accelerant. The unusually warm coastal waters trigger explosive growths of harmful algae. These blooms saturate the water with domoic acid, a potent neurotoxin. Small fish consume the toxic algae, and it travels straight up the food chain. For indicator species like the California sea lion, the concentrated toxin causes severe neurological damage, reproductive failure, and widespread starvation along the coastlines. Meanwhile, massive predators that rely on those vanishing fish populations are forced to hunt right along the shoreline. By moving into shallow, heavily trafficked waters, they face a drastically higher risk of fatal collisions with ships and entanglement in commercial fishing gear. Decades of population stability for apex predators like humpback whales are being erased by mass starvation events and physical trauma from coastal displacement. A localized shift in ocean currents cascades into a toxic collapse of the entire coastal ecosystem. That massive transfer of heat from the ocean to the atmosphere physically alters the Pacific jet stream. It forces the high-altitude winds southward, violently shifting global storm tracks off their usual paths. This is a global forecast model for precipitation during the summer of 2026. The brown zones highlight regions with a high probability of severe rainfall deficits. Warmer air holds on to its moisture instead of dropping it as rain, pushing traditionally dry areas across Central America, South Asia, and Africa into deep drought. Zooming in on the Greater Horn of Africa, the deep red and orange sections indicate areas facing critical rainfall shortages. These are regions where rain-fed agriculture and pasture land are the primary means of survival. When multiple planting seasons fail back-to-back, the ground cracks and food production plummets. Herds of livestock perish from heat stress and dehydration, decimating local economies. A shift in atmospheric pressure over the Pacific transforms scattered weather anomalies into synchronized, devastating shocks to global food security. Back on the coastlines, the altered jet stream and the physical expansion of warmer water push the ocean higher, driving those tides further inland than normal. Today, that seasonal surge sits on top of a permanently elevated baseline. Decades of greenhouse gas emissions have steadily melted ice caps and expanded the oceans, bringing the water level to the absolute brim of our seawalls. The result is catastrophic high tide flooding. Commercial and historic districts are inundated with knee-deep water, shutting down local businesses and destroying infrastructure. Because these storm surges are launching from a higher starting point, they punch exponentially deeper inland, swallowing entire residential neighborhoods. Coastal communities face the compounded destructive force of a permanently expanded ocean. A super El Niño commands the atmosphere with millions of tons of displaced water and heat, dictating whether coastal cities stay dry and global food grids yield a harvest. We have zero authority over this mechanism. The shifting of the Pacific trade winds is a massive, unstoppable cycle of nature. But we completely control the baseline temperature that makes this cycle so destructive. The burning of fossil fuels directly injects the excess heat that amplifies the natural swing of the pendulum. The sheer violence of the 2026 El Niño is a stark mathematical warning. Our survival depends on aggressively phasing out carbon emissions and rapidly scaling renewable energy grids. Decisively transitioning to clean power lowers that global baseline. If we pull the excess heat out of the equation, human civilization can actually withstand the extreme cycles of tomorrow.